everyone, so today we are solving another interesting problem, number 567, permutation in a string. And the problem says given two strings s1 and s2, return true if s2 contains a permutation of s1 or false otherwise. In other words, return true if s1 is permutation is if s1's permutation is the substring of s2, and the length of s1 and s2 are given, and s2 and s2 will consist of only lowercase characters from English. Okay, so to solve this problem, what I can do is we have one s1 and we have one s2 strings, and and we want to check that if s2 contains one permutation of s1. And so what we can do is we can get a character count of both these strings. So if the character count for string 1 would be that a has come one time, b has one time. Similarly, we can find it for the string 2, and what we can do is we can put two pointers at a distance of difference between the length of s1, and we can keep traversing this pointers and adding and removing the characters in the hash map 2. And as we are traversing, and once we reach a case, if we have found the characters are equal, then we'll return true. If not, then we'll return false. So if we add b1, then we'll remove i1. The next character that we'll add is a1. We'll remove the previous characters from the two length before the character that we have seen in the string. And similarly, when we add o, which is initial count would be 1, then we'll remove b, and if then we increase the more count, then more count. And the case that when we had a and b as 1, both equal in the hash maps, we'll return the true case, and if they are not, then we'll return the false case. Okay, so and this is how we can write this problem down. So let's write it out. So first we need the length of both the strings s1 and s2, and we need hash maps of s1 and s2. And we'll start traversing the string 2. So we need the characters till we are there in the number of characters that are there in the string 1. Same number of characters we want in the hash map of 2. So now first we'll check if my count in both the hash maps, if the characters and their count in both the hash maps are equal, then it means that s1 is present in s2 and will return true. Otherwise, we'll add one element and we'll remove that one element from the hash map 2. So we can do it like this. 2, and we need to remove the character, that is SR minus length of S1, and then the count of this becomes 0. We'll delete that character and its count. So count 2 S R minus N1, and at the very end we'll compare both the hash maps for their total number of characters and their count in the hash map. Okay, so and one edge case that is not clear in the problem, but could be that if my length of S1 is greater than the length of S2, in that scenario I want to directly return false, because that is not possible. So now let's run our code and see how it performs. Okay, so this is from the string 2. This can happen to you as well, no worries on that. Okay, so it has accepted our solution, and let's see how it performs. Okay, so it is good, it is fast. So that's how you solve this problem. And the time complexity for this would be O of n, the number of strings in n2, because that number of strings in that are the number of elements in string 2, and the space complexity is again O of n2, because it is actually O of n2 plus O of n1, and the master theorem tells us that this sum would become equals to O of n2, because n1 is less than n2, so the dominating space complexity would be of n2, because that's the length which is bigger in size, and similarly for the time complexity. So yeah, thank you.